Broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to today's Tech Talk on fire stopping, maintaining rated systems. My name is Sherry Adams, and I'll be the moderator for today's session. Please note that throughout the Tech Talk, all phone lines will be muted. This will minimize any background noise or feedback that could distract from the presentation. When you first joined the Tech Talk, an attendee control panel appeared on the right side of your desktop. On the left side of this control panel is a small tab with an arrow icon at the top. Pressing this icon allows you to minimize and maximize the control panel. When maximized, you could use the control panel to submit questions. We'll be gathering your questions throughout the Tech Talk, and we'll leave a little time at the end for Q&A. If your question is related to a particular slide, please include that number of the slide in your presentation or in your question. A PDF of the slides from this presentation will be sent electronically to all of those who register for today's Tech Talk. We will also be recording it and will be available on our website under the resource section. The current password to access the Tech Talks is TechTalks18. Do look for a new password coming next month. Today's presenters are Rachel Reckert and Dave Gubrud. Rachel and Dave are both partners at Ring and Du Chateau in Brookfield, Wisconsin, where they co-lead the commissioning department. They both attended the Milwaukee School of Engineering, where they obtained degrees in agricultural engineering. Dave in '96 and Rachel in 1999. Rachel obtained her master's degree also from the Milwaukee School of Engineering. When not working their day jobs or parenting at their respective homes, Dave is a part-time teacher at the Milwaukee Area Technical College, and Rachel is an adjunct professor of MSOE. Both are also active members of the BCA, where Dave was a Central Chapter Board member, and Rachel is a current Central Chapter Board member and secretary. Their favorite mantras are, we play with our cards face up and make it personal. So Rachel and Dave, I'm going to turn it over to you.
Thank you, Sherry, for that introduction. I'm Rachel.
And I'm Dave Gubrud. Thank you guys for joining us.
We're here to talk to you about life safety.
Or as we often see it, which we don't want to see it, life maybe.
Oh, look at that, I got to click out already. So why protect or rate wall systems? What it really comes down to is that first line, making the building and its occupants safe during an emergency. So you want to make sure that you're creating that path of egress that can be maintained for a duration of time if there's a fire or smoke event, or a defendant's place location.
What we're going to learn is that just even small cracks and
what's that?
Oh, our projectors, our screen freaked out for a moment here. There it is. We might have bumped something. So we're back. I think everyone's seen the right screen. So, you know, fire and smoke can spread quickly through even the smallest of gaps and cracks. So what we want to be talking about is the,
I don't know what's going on here. This is the first time this is happening. Someone is playing with it right now. That's not.
I'm sorry, we're using our little hockey puck for video, and it's like somebody has
taken control of my computer.
Commandeered our screen. Right? That's what's happening.
Sherry, can you confirm if people can see the PowerPoint right now?
Yes, we can see the PowerPoint.
Okay, so we will continue off of my computer here. All right.
Okay, we're just going to move around and look off of a surface screen.
Yeah. Okay. Sorry for the interruption, everyone. I think they're doing some IT things here suddenly. Okay.
We're good. Next screen.
Yep. So we're going to start this off with a little video. It's like 1.5 minutes. So just to kind of get the feel here.
So what we're showing is the Rhode Island Station Night, or the Station Nightclub fire. There was over 100 people that died in this fire, and we're not indicating that fire alarm and the lack of fire protection caused this issue. and have all these steps, but just really trying to indicate that a fire condition and a fire can just happen very quickly and create really a chaotic situation.
So as you can see, the fire alarm indicated in 30 seconds, and it progressed very quickly at that point. Right now, it's probably about 4 minutes into the fire, and the entire building is engulfed. So basically, that's the gist of it. So the point of this is just to show that fire spreads very quickly. And so part of what we're trying to do as an industry is we're trying to maintain those paths of egress and those ways to keep people safe going, exiting buildings. So let's continue. So this screen here shows a lot of statistics. And Dave, what do we typically say about statistics?
My favorite sign that I saw on a construction site said 87.564% of all statistics are made up. So, these numbers here can be, very daunting, but truly what are they based on? But what it's really trying to convey is something that we actually indicated in our mantra about making it personal. That it's really important to know and to consider that when we're talking life safety, and especially in healthcare, but really anywhere people are at, but using healthcare as our prime example, we need to consider that that might be our grandmother, our wife, our husband, our daughters, our kids that are, in that hospital bed or in that surgery room. So we need to truly make sure that things are safe so that, again, like that chaotic situation, now granted that was a nightclub, that those type of things don't work their way through. We have to make sure that things are safe.
Right, and as you can see here in these numbers, that a majority of these deaths were caused by smoke. So, a number of years ago, all of these protection devices were really geared around fire, and they have determined that most of the deaths have occurred due to smoke inhalation, and that's even, even a majority of those were from people who were not even in the room where the fire originated. So a lot of the changes in the products and the testing has revolved around smoke. So how fast does smoke travel?
So just as a simple example, and unfortunately we don't have a little video to go along with us, but a simple 10 millimeter hole can actually have smoke traveling through that hole anywhere from 120 to 420 feet per minute, bringing, the smoke into a safe area. So again, we need to really truly make sure that these gaps, these holes, are, whether or not they're vertical or horizontal, are truly closed so that we can keep smoke within, from, inside of the smoke barrier where the condition is occurring.
So obviously, when we're out there doing our site inspections and we're getting all this grief for, making comments about this little hole, it's valid. We had a rep come in to talk just to kind of, while we're making this presentation, just to kind of get a handle on, are we being too stringent or too tough on people? And we kind of walked away with, we're not being tough enough still. So it's, pinholes matter. So what's out there? There are many types of fire-stopping products, whether it's caulking or devices. There's many different suppliers. This presentation is going to focus on fire caulking through wall penetrations, and it will also cover a little bit life safety dampers. But we do only have the 30 to 40 minutes, so this is essentially a teaser because this presentation could go in so many directions and you could spend a lot of time on individual things. So how do we maintain our rated wall systems? Well, there's fire stopping techniques and there's life safety dampers, and these are both UL listed assemblies. And that means that they are tested in a specific manner that they are installed. So in order to maintain that UL listing, you need to install them in the specific manner that they were tested. So, if you are ever deviating from that, that comes down to engineering judgments. So it's important to follow those installation instructions.
So the two types of fire stopping, we need to make sure that we're using the right type of fire caulk, for the right type of caulk is being utilized. So we have the intumescence, and that is the type of product that actually expands when it's exposed to fire. It can be a paint, and then it can also be like the pillows, the putties, those pre-made assemblies that that manufacturers make that can block the gap again in case there's a fire, such as cable tray penetration, as we indicated, cables and pipes. And then we also have the elastomeric or whatever, and I always love spelling that. I'm an engineer, not an English major or pronunciator. So, and this is the spray applied that we would often see up at the joints. And the reason that this is a really good type of barrier is that this actually has more elasticity than the previous mentioned caulk, because sometimes these joints do move as the building moves.
So what do all the letters and numbers mean? So when you're going up to a penetration in the wall, and there's that tag up there, that WL1054, we all see that one quite often. So the W stands for wall, the L is gypsum wall, the 1000 series is a metal pipe, conduit, or tubing. Whereas the 2000 series in the next example is a non-metallic pipe, conduit, or tubing. So you see a 2000 series used oftentimes with the smaller PVC piping, for example. So there are charts that are out there that kind of spell some of these out. You can see the first letter, second letter is the series. And then there are also, if you want to get more specific, you can find some of these in some of the product catalogs sometimes. But you can kind of almost figure out what the number should be without even looking at their tag. So who is the expert?
So is it that installing contractor? Is it a third-party fire stopping contractor? Is it the authority having jurisdiction? Is it us, the commissioning provider? Is it a combination of these? Is it all of the above? Is it none of the above?
So let's talk installing contractor. Who typically installs the fire caulk?
I know. It's the guy they just got out of the hall, right? Been here with, for 2 weeks.
You mean that free apprentice?
Yes, because it is the easiest job, right?
I think you're right.
But in fact, it is not the easiest job, and it's probably one of the most important jobs. So it really does need to be done by a person that is, we have the written word, we have the word certified there, but what they really need to be is truly trained in this. And so the who should install it is somebody that truly has experience, someone that can truly teach somebody how to do it, and
somebody who understands the purpose of that rated wall, really, because the entire purpose is that, the purpose is that you're not going to allow fire or smoke to penetrate through that wall.
And again, who should verify these installations? Again, just using our processes, right? The contractors really need to have their own quality control places or processes involved to make it work. Again, we're the quality assurance, but as we probably are all nodding our heads, so many times we get drawn into being the quality control that we're not. So the contractors really need to have that verification that it's done properly, and whether or not that's a specialist within our organization, we're not sure. It can be multitudes of people, but it never seems to be the right people.
Correct.
Third party, who typically installs fire is an entity that just truly installs this. Now, granted, there can be advantages of this because it's just the true one entity, single source, but we have run into conditions that Rachel will expand upon.
Yeah, we were on a project recently, and the fire caulking was installed not great at all, I guess we could say. And essentially the entire building was a fail, and everybody had installed their own fire caulk. And so the general brought in a third-party fire caulking company, which that's all they do. And they came through, and they were like, okay, Rachel, we're ready. And I went in, with one or two of my other folks here, and we must have gone back 3, 4, 5 times, and it would fail every time. They got about 50% better. But this is a third-party company that all they do is fire caulk, and they were putting, different products on top of each other. The tops of conduits weren't fire caulked. some areas were completely not fire caulked. You know, the examples were, there were many examples of failure in that building to this day. So, you know, even though you're third party, it still needs to be verified. You know, it really comes down to the individual and your experience level with them and their quality.
The authority having jurisdiction, you know, just those simple responses that we show on the screen there, some do have an understanding of the system. Some do visually verify. Some do the destructive testing. Again, to Rachel's point, it does come down to the individual. You know, the old adage that's oftentimes that the authority having jurisdiction will say that, you know, red is right. You know, that is not the typical term anymore because, number one, fire stopping can be different colors, but not only to that, which we'll be expanding upon, is that you can't necessarily just put fire stopping everywhere.
Right.
And now it comes to us, and kind of as commissioning providers, and a lot of the same things hold true. And we know what we do, and to be candid on that, you know, depending on our clients or whatever, is depending on, okay, we're always looking at it. We're looking closely. But some owners are really wanting us to be really the driving force behind this. As Rachel indicated earlier, you know, being the ones that people are saying, hey, that's only just a little hole, is that important? Yes, it is important to be filled in. But no matter what the job, from a commissioning perspective, we are the owner's eyes for looking at these technical aspects. And if we're not seeing something correct, we are passing that information on. So it's, as our bottom line indicates there, you know, are we experts? No. Do we oftentimes know more than others? Yes. But are we dangerous? That's a for sure yes.
So, like you can see here, life safety.
Or life maybe, the omelet.
Right. So really, are there any experts? So let's use Hilti as an example. They have, you know, probably thousands and thousands of people that are manufacturer trained, and this is not a certification process. This is, you know, a representative coming to a job site or to an office building or somewhere, and they're training for 2 hours or 4 hours, a group of people on the whys and hows and such as to the process. Then there is the Hilti Fire Stop Specialty Contractor, or an HFSC, and this is an accreditation or a certification that approximately 100 companies in the United States hold. And this means that at least 70% of their work is installing fire stopping systems. They're audited annually by either FM or UL. They pay a fee annually. They have to participate in various training, so on, so on. So even given all this, is there still room for error? Absolutely, because as it says, approximately 100 companies in the U.S. hold this accreditation, not 100 individuals. So a company holds this accreditation, and they bring in new people, and those new people are technically covered under the company. But it really comes down, in our opinion, you know, we're opinion-based, it comes down to the person, you know, the passion of the person, I guess you could say.
So how do we help from a commissioning standpoint? Probably using a couple of big tools that we all have in our tool belt. One is actually participating in leading or in pre-installation meetings pertaining to fire stopping, a really good thing, and even fire smoke damper installation. Utilizing construction verification forms. Again, utilizing those as the little reminder forms to the contractor, have I done this, have I done that?
Right, and then also, you know, should there be a CV form for fire stopping? And if so, what would we want to put on it? But when we asked the manufacturer, their top 3 items were, is there sufficient annular space? Is there the proper depth of caulk installed in the wall? And has it been tooled appropriately? And then on top of that, we listed some more items, such as, is the system identified on the tag? And
properly identified.
Properly identified on the tag, which we'll talk about as well. So, you know, certainly, would you do this per room and per trade? Maybe it would be each each trade in each room that has a rated wall would have one CV form where they, once they're completed with their penetrations, they could fill out the CV form. And once again, just so you know, we're all kind of on the same page, we're just here creating awareness because this is an issue in the industry, right? As Dave indicated, are we the experts? No, but we know that this is an issue in the industry and it's important that the awareness is out there. So let's kind of breeze through, and we've got a number of pictures, we'll breeze through these pretty quickly, of some issues, and we're starting on the life safety damper aspect.
So we really love the framing on this one. Oh wait, oops, there isn't any framing on this.
What framing?
On this fire smoke damper. And you know, so it literally can be things that literally just jump out at you. So, you know, that is certainly a condition or whatever that of inappropriate installation.
Right, and we're talking the framing and not the retaining angle because those are two separate requirements for a life safety damper. And that also is probably its own full presentation as well, life safety dampers. So this is one of my favorites. But you can pretty much just throw a dart at this picture and walk away with something, whether it's framing or you're fire caulking into the wall, a fire smoke damper, or you don't have access, you don't have retaining angles. I mean, we can pretty much go on and on. So, and we've kind of summarized a lot of the issues into one issue versus having, you know, multiple. Here we've got retaining angles around the life safety damper, and they're screwed into both the sleeve and the wall, and there were retaining angles on both sides of the wall. So the requirements are, if you're on both sides of the wall, you can only screw into the sleeve, not into the wall. So if you are, for example, on a shaft wall where you don't have access to the inside of the wall, that would allow you to be able to do it similar as shown with screwing both into the sleeve on the wall as long as your spacing of screws is appropriate. No access door, even though the wall isn't built yet. So here, it didn't seem like the damper was moving, but it turns out that the end switch linkage is lying on the bottom of the ductwork. So we'll reattach that. Life got better. And moving on to, so we've just breezed through life safety dampers. Right now we want to focus a bit more on the fire caulking aspect. So here we have a tag, and what we do many times is we sample through, we take some tags and just make sure that they're appropriately labeled for the system. In this case, the tag was correctly labeled for the system. And by correctly labeled, you see the WL1054. That's where we're looking.
But here we have an example of things that aren't correct. And maybe by a simple look, you're saying, okay, we have the elastomeric on there, but unfortunately, we also have the intumescent caulk that really shouldn't be there as the bead. So that's not an appropriate means of fire stopping. There shouldn't be that type of fire caulk on the fireproof spray. And here's another example of something similar again with our little.
Okay, the yellow circle moved.
But
shift it up an inch and you're there.
We're not talking about the ASTM number on the sprinkler pipe, but we're talking up there with the mineral wool, again, attached to the fire proofing on the steel beam, attached that, again, that's an inappropriate use of fire caulk.
Right, that should have used that fire spray with no fire caulk.
Again, this is just one of our favorite classic pictures or whatever, more because of what's behind the door of let's make a deal. There are, in fact, drains, and that's what they wanted to do, but there are other issues on here with just, again, the liberally applied fire caulk. You know, the screws aren't covered, and actually they're not even supposed to be covered. The seams are fire caulked. Those aren't supposed to be fire caulked. The seams are not supposed to be tied together with fire caulk. And which we'll dig into that momentarily.
Yeah, there's a whole slew of issues on that page. So here we have one of those items that could have been maybe better serviced with one of the twist devices. So we've got the sleeve that has all these cables running through it, and we all know that people come through and they pull cables later and out comes the plug, and it is no longer sealed. So we talk about that 1/4 inch hole. Well, this is much larger than a 1/4 inch hole, so a lot of smoke can get through this. Additionally, a lot of the requirements on some of these is that the cables on both sides of these sleeves need to be bundled. So here you see a smoke barrier wall, and they just kind of ended the rock when it ran into the insulation of the pipe. So I'm sure that's maintained somehow back there. But so that's an issue. You can see fire caulk. You know, everybody, it's important, get up on your ladder, look at the tops of pipes at the tops of conduits, because even though this is installed very sloppily, the top isn't installed at all. Here we've got a gouge in the smoke barrier wall, and the rating is based on a specific thickness of your layers of rock, and when you're gouging a 1/4 inch out, it needs to be repaired with mud. You can see here the fire caulk pulling away from the pipe, and another item to note is fire caulk has water in it, and so as it dries, it shrinks. So the reps that we spoke to last week basically indicated if you want to maintain a 5/8 inch depth in the wall, you need to install more than a 5/8 inch depth into the wall, so that when it shrinks, it ends at 5/8 inch depth. So, and I don't recall, that's something we'd have to verify with the manufacturer, how long of a dry period it was like a week or two. But it is something that should be gone back and looked at. And I guess if you think about it, that's similar to fire dampers. A lot of contractors want to test their fire dampers right away. And then we go and we put in ceiling grid, and we put in fire alarm devices and grills and lights, and suddenly there's, you know, the access point to your damper is gone. And so it's important to test those late in the game so that you truly can verify they give access to these, you know, to be able to move the damper and adjust and reset the linkage and all that kind of fun stuff.
I always seem to get the ones with the fireproofing, right? So here's fireproofing that literally is just missing again on the beam or whatever, and so that's our main issue right there. I believe you have to point to that or whatever, because is that the drywall actually is, or the wall is still not covered with the caulk. That was what was our issue.
Right.
In the mud there, right? Is
Right.
what the problem was.
You can see that in a lot of these cases that the wall is tight to the device or the penetrant, and so there should be a bead, and each individual installation sheet would indicate this, but there should be a 1/2 inch bead if it's tight to the rock. Here, it looks like somebody's maybe yanked on the conduits or however, but you can see there's no fire caulk inside that hole anywhere. They just kind of smeared it around and made it look red. You can see the hole into the space in this fire caulk. And we did ask the question if there was ever a hole in the fire caulk, and this maybe isn't a good example, but even if you had one that looked like a nice installation, there's just one little hole, they said that's it might be okay, but it's an indication that something probably wasn't installed appropriately. And if it was a firewall, is that an issue? Probably not, because it expands. If it's a smoke barrier, then that is an issue. Here, it's another issue with the plug pulling out of the end of the sleeve, as well as it looks like that conduit could potentially be tight to the wall, so I'm not convinced that there's 5/8 inch caulk in there, and then I don't see a 1/2 inch bead either. And once again, looking on top of your penetrance through the walls, it's really important. I can't really stress that enough. We've walked into many facilities and you just look up and think, oh man, that looks beautiful. I mean, there are times where it looks like a little piece of art. They've taken their time, it looks nice, but you climb a ladder. Everybody needs to climb a ladder, look at the top, and make sure that it truly is good. Here you can see it's pulling away from the pipe, so whether it's drying or wasn't tooled appropriately. This, it looks like someone maybe leaned on the pipe or conduit and kind of broke away from the wall, so it needs to be repaired. This is just, you know, a couple of things.
It was like a heart. Did someone take a heart and just lay it on there?
So obviously it was never tooled, but you know, these are things that just they draw your eye to them, and you know right off the bat that they're not installed appropriately because they're not even tooled. The wall is close enough to this where you can't get 5/8 inch into the wall. So this is where you would use your 1/2 inch bead, and this is just a blob. Here, obviously, you can see it's not tight to the pipe. This, you can see the drywall through the caulk. So it's tight to the drywall, but there's no bead. And this.
That's my classic picture right there. I mean, we are fire caulk on the bottom, but they really missed the top on that one.
Yeah, you might need a drywall patch. And here, this is one where you can see here, they're calling out the system WL2098. So this is one of the examples where we go and kind of check the system, make sure it matches. And Google works good for that, everybody, when you're sitting out there on site. But you kind of pull up your sheet, and you can see here that it says a maximum of a 2-inch PVC pipe. This is a 4-inch PVC pipe. So this is the wrong system for this pipe. And the reason for this, I mean, if you think about it, when you get to the larger PVC pipes, you have that intumescent fire caulk that expands, right? But if it's too large of a space, it can't expand to fill that whole space. So it's really important to use the right system to do that. So that fire caulk that they specified to fill in the wall 5/8 inch could do up to a 2-inch PVC pipe. You get bigger, they have different systems available. Quiz. A plumber and electrician walk into a room. So anyways, if they have 2 items respectively located a couple inches apart, and during the installation, one of their products touches the other product, is that okay? Is that a life safety code issue?
When there are 2 separate products, right?
Correct.
There's a Hilti product and a 3M product.
Yes, that is what I mean. Because any Hilti product can touch a Hilti product, any 3M product can touch a 3M product. But we're talking if a Hilti product touches a 3M product.
So the answer to that question is no. 2 materials of different manufacturer may not touch each other. And it's actually pretty much a simple answer, is that, as Rachel indicated earlier, all of these systems are tested by, to a UL standard and getting to the UL listing. And none of these manufacturers are going out there and saying, hey, 3M, hey, Hilti, let's go and test our product together to see if we actually have a problem. And so the simple solution then, or the answer is 2 products of 2 different manufacturers cannot touch each other. And that's because there's a potential, because there's different chemicals in these devices, that they can cause a chemical reaction that is not the way of it.
It's
not the anticipated way, because it hasn't been tested. So, okay.
Is this a life safety code issue? It is, because IBC requires that all penetrations to rated assemblies must use an approved and tested system. So tested is UL.
But going to the simple pieces, as we indicate, mixing a fire-stopping product, is a definitely big no-no. Will it likely work in the grand scheme of things? Probably yes. But does it maintain its UL listing? Again, that goes back to a definite no, and that would be the Trump device or listing type of thing. So it goes back to the no. Can we just use the word Trump?
Dave just brought in politics. Okay. Some more issues. This is kind of building off of what we were just talking about with combining using 2 different products on one wall. And this might be why a lot of job sites go to using one product in their entire job site, so that they never have the potential for 2 different products to touch. But while there's a lot of things wrong with this wall, it was really just to show that we have 2 different products labeled as different tagging systems. So in this case, you can see that multiple fire caulks were used, and they're right over the top of one another, and that's definitely a big no-no. And that was in the building where they brought in a third party. So just winging through these pictures, we're missing plugs, we're missing fire caulk. We've got raw edges of drywall that aren't addressed in this rated system. So if a large hole was cut in the wall to install duct and the opening was determined to be too large and you had to do a drywall patch, Is it acceptable to seal the drywall patch to the drywall with fire caulk?
Is it acceptable to seal a drywall patch with one layer of drywall mud?
Can drywall mud be installed over the top of fire caulk?
Does drywall tape need to be coated in mud?
Do the drywall nails or screws need to be coated in mud? So, is it acceptable to seal the drywall patch with fire caulk? No, drywall to drywall seams must be coated in mud. There is no UL listed system to use fire caulk between drywall and drywall.
And a drywall patch cannot be done with one layer of mud, but it really just needs to simply be done with 2 layers of mud.
And mud cannot be installed over the top of fire caulk. You must first remove the fire caulk and then install the 2 layers of mud.
And when drywall tape is necessary, which typically it is for seams, then again, the 2 layers of mud are required.
And the same applies for the screws and nails. They must be coated in 2 layers of drywall mud to maintain that wall rating. So here's an example of fire caulking a drywall patch. So they had to remove the fire caulk and they had to install the 2 layers of mud. Here, this is just, we walk through these rated systems with our flashlights up at the edge of the wall. And this is just us questioning how are they maintaining the smoke barrier at this detail. So sometimes you just have to point it out. You're creating awareness for people and they can come in and fix it. It's not that we know exactly how they make that particular fix.
And again, it goes to that 10 millimeter hole can go from 120 to 420 feet per minute. That, this is even a larger hole, depending on pressure from one side or the other, it could really be drawing smoke through.
Exactly.
And here's another example of standing on the ground and looking up through all of the wire tray and saying, hey, I see a seam there. And again, this is on a rated wall assembly. That doesn't look right. So again, going up on top of a ladder and looking above the duct, we again see that truly the rated wall is not seamed with the mud and the screws are not covered.
Right. So, and Dave kind of talked earlier about who's, and this comes down to the drywaller too. What guy is taking care of what walls, right?
Yep.
What person. So just some more examples of the wall rating, being tape or holes. Here, multiple things wrong with this picture, but let's focus on the positive for a moment. Look at that wonderful putty pack. There are devices that are offered by suppliers that can take away the error. And the problem with fire caulk is it's pretty much about 80% human error with an installation process. And if projects would spend a little bit of extra money in the beginning, they could have devices which would take away that error aspect. This little putty pack is good for anything 3/4 inch and down, but whereas if you look at the fire caulk that was installed up here, I have a feeling there's multiple things wrong up here, which will require a revisit or 2 or 3. So by the time it's all said and done, the cost is probably similar. And once again, just drywall patches. Here, this one, we have a 3-inch and a 6-inch PVC pipe, and they used a specific system, which is not correct. The system was made for a maximum of 2-inch PVC pipe. So they have these systems that are made for larger pipes, but
they identified them wrong. Right?
Well, they were identified wrong, but they also have to go back and get an engineered judgment on PVC piping that's as big as it is, because it might require additional wraps of the filler material that they put in there. So it's important to pay attention to the tags and make sure they're using the right systems.
This is the spray foam type, expandable foam. Again, it just begs the question. This likely is a working system, but again, just on how it just kind of contorted and almost looks like the movie Alien, it just doesn't necessarily look correct.
And they did indicate when we showed a rep this picture that they would be fearful that something was actually installed wrong in there just because it looks like a big hot mess. These are discussion plates underneath the sink going into a wall, and it's interesting, we pulled them back just to make sure that things are fire caulk, but it's interesting to see how many things are wrong back there. So, look down also and behind, going into walls under sinks and things like that, because it's not always pretty there either. This is an example of where the wall was not patched, prior to the installation of the ring. So obviously you can see the whole outside of the ring. So we've got issues. And once again, you see stuff like this, and this is not proper. You need to tool. You need to have a bead. So destructive testing, what does it mean? Who should do it? What do you look for? Number one, is the tag labeled appropriately? And check out that installation form. This is the installation form. If you zoom it up on it, it gives you exactly, hey, number 3 there is the annular space. Or if it's tight to the wall, it gives you what it's supposed to have in there. So if you read number 3 here, minimum 5/8 inch thickness of fill material, so minimum after it's dry, applied within the annulus, flush with both sides of the wall, at the point of continuous contact locations between pipe and wall, a minimum of a 1/2 inch diameter bead. So if you tool that bead, you just need to make sure that at the point of intersection of the penetrant and the wall to the center of that bead is a minimum of a 1/2 inch. What tools do you use? You can use any assortment of tools. I like to use this one because you can put it in there and you can pull out in that right angle of the pick. Basically catches the firecock. You can kind of see how deep it is. But going prepared with a utility knife, these types of tools are helpful to getting the firecock out. We do utilize a, if you want to call it a sampling functional testing form, just to kind of go through and sample destructive tests at various locations. It is important to document and tag where you're testing so that they do get repaired. And a lot of times the GC or someone wants to go along with us anyway. So whether you're hanging tape from that location or just so it's clearly defined where you are. This is an example of one where we dug the firecock out, and you can see that there's plenty of space where they could have put firecock into the annular space, and they did not in this case. It was all on the outside. So the general rule is if there's sufficient space around the penetrant, you should be putting the firecock into the wall. If there's only an 1/8 inch space, we all know it's kind of hard to get 5/8 inch firecock into the wall, so doing the bead is probably recommended at that point. But if you have a 1/4 inch, 3/8 of an inch, there's no reason that firecock isn't in the wall. I'm speed talking. Do you want to take over here?
No, you're doing very well, Rachel. But the important one is of MC cable. You know, oftentimes running parallel to the wall, which again means that inner radius might not have again the appropriate level of caulk going through it. So that's, again, just those inside corners really truly need to be looked at to make sure that it's done properly.
So what should we look out for?
So we certainly need just to make sure that the fire stop system is utilized in the first place.
Exactly. And maybe that it's tagged appropriately and filled out.
There isn't a one correct system for it all, right? And like in Lord of the Rings, there's the one ring to rule them all. This is not the case in this instance. So you have to make sure that you are utilizing the proper system for the proper devices that are going through that wall.
Absolutely. And there should be no gaps.
The volcano of just piling up the fire caulk to thinking that you're really sealing the hole, you're not doing anything but begging the question that it's not done properly.
Right. And always check the top, because if they're going to miss one of the sides, it's going to be the top. And obviously making sure the annular space, the depth of the firecock, the fact that it's tooled, that those are all in place. And pretty does not mean properly installed.
That is a big one.
All right? Just because it looks good doesn't always mean it is good.
So maybe, Sherry, I don't know, we're running right up against our time, and I know this video here. Do we want to ask, are there questions to ask?
Well, there are 2 questions, Dave, that we do have if you want me to ask them really quick.
Sure. The video is a 3-minute video, just to give you a heads up.
What was that? I'm sorry.
The video we were going to kind of close with is a 3-minute video, just to give you a heads up.
Okay, perfect. Then let me I'll ask these 2 questions and then.
Perfect.
Yeah. It says, the first question, do you see fire department inspectors review the fire caulk installation?
Do they? I think kind of what Dave was talking about before is I think it depends on who and where and what that person does. Do they look at it? Yes. I think that they do. Do they analyze it or look at it closely?
We have one.
Perhaps they do or don't.
We have one big municipality, not the biggest municipality in Wisconsin, but it's the one that has the beautiful white building with the dome in it. That their fire department is over the they scrutinize everything and pay attention to that. But we can go to other municipalities, southeast Wisconsin, other areas, and the fire department and looking at this aspect isn't involved much at all. They're looking more for pathways, where the horns and strobes are, where they can run up and down the stairs, move their hose connections to, and that type of thing.
Right. I'd say it's probably one of the areas people who look at it the most are CMS and Joint Commission, who come in a couple of years later, and life gets really difficult for those owners at that point. So anything we can do for the owners early in the process during construction, I mean, that's the time to address it, because it's going to be really difficult. A lot of heartburn, heartache. The building is occupied on the road.
Okay, great. And then are there any code standards that define life safety installer requirements?
That define life safety installer requirements?
Correct.
Like a certified person? Or
I don't know the answer to that. I don't know.
I'm not certain.
Okay.
I've not heard of a code requirement for an installer, but that doesn't mean that it doesn't exist. Like we said,
Okay.
yeah, I don't. The same would be for testing. I'm not aware of there being any certification or code requirement for a certified test either.
And again, we're from Wisconsin, where we just implemented the IMC 2015 in May, and they actually took all the commissioning requirements out of it in Wisconsin. So
Okay.
Wisconsin is its own special entity.
Okay, and then we did just have one more that just popped in, and then we'll let you move on to the final video, and that is, can you explain tooled and the 5/8 caulking requirements more?
Sure. So the 5/8, if you look at any of those sheets or the product that you have, it shows the picture at the top usually, and it shows the description at the bottom. And it says, for a 1 hour rated wall, you need to have 5/8 inch fire caulk deep into the wall around your penetrant, so around your conduit or around your pipe on both sides of the wall. So you have to go in one room, 5/8 inch deep. You have to go into the room on the other side of the wall, 5/8 inch deep. If the rock is tight to that penetrant, then, and keep in mind everything I'm saying right now is contingent on a specific system. So you have to look at your system. But if it's tight to the drywall, then you can have a 1/2 inch bead, which really means you're caulking around the edge and you're tooling it, and you're making sure it's a 1/2 inch thick from that center point to the to where it touches the wall. I think the other part of your question was the tooling aspect. I just went to Ace Hardware and bought one of those little right angle pick tools, and I use that.
But there are trowels and stuff that get
for putting, yeah. Yeah, and you'll actually see that in our video, on how they are actually installing some of the fire caulk on a pipe.
Great, thank you.
All right. So we're going to, this video is a Hilti one, but I'm assuming most manufacturers have a video of their own. So
I thought it was pretty interesting.
It is interesting. It's how they test it internally.
And it actually shows what's happening on the fire side.
It does.
And, maybe the one thing of giving the teaser.
Hemisphere Product Development Center, you're in our North America Fire Stop Testing Facility, where we test all of our fire protection products in accordance with UL, CUL, and ASTM standards. There are 2 furnaces in this facility. The one on the left is used to test floor or ceiling applications, while the one to the right is for wall applications. The testing process begins in our prep area. In this example, the assemblies consist of plastic, insulated, and non-insulated pipe penetrations. Hilti Fire Stop solutions like FS1 mats and Fire Stop collars are installed around the pipe. Once the assemblies are built, We add thermocouples to measure heat transfer through the assembly and the pipes as required by the testing standards. As final touches are put on the assembly, technicians prepare the furnace and afterburner. The afterburner is a high-powered incinerator that burns the smoke and gases generated by the test itself. When it's ready, the assembly is carefully secured to the furnace. Lead wires from the thermocouples are attached to the monitoring system and tracked with our computer program. With a mouse click, the furnace's burners are ignited and the test begins. In a few minutes, the PVC pipes and insulation on the fire side of the wall melt away, causing them to ventilate smoke into the room. Heat causes graphite in the product to expand, creating a seal that continuously expands as long as the heat is applied. This closes the pipe and limits the passage of smoke and harmful gases into other parts of the building. After 10 minutes, the temperature in the furnace is 1,300 degrees Fahrenheit. The burn test can last anywhere between 1 and 4 hours, depending on the assembly being tested. As the last few seconds tick away in this 1-hour test, the temperature in the furnace is 1,700 degrees. Our products have done their job to protect the penetration and to keep the fire on one side of the wall. As you can see, there's not much left of the pipes exposed to the fire. The fire side of the assembly will now be subjected to a powerful stream of water. We use an authentic fire service hose and nozzle during the test. Distance from the wall, water pressure, and spray duration are all dictated by ASTM and UL test standards. As the water hits the superheated sheetrock, it practically explodes from thermal shock and impact of the water. This type of test helps determine structural integrity of the fire stop system. As the charred wall disintegrates, most of the assemblies and leftover pipe go with it. But on the non-fire side, the assemblies remain in place exactly as designed.
So as you can see there, it was interesting seeing how, as that PVC pipe, so that 4-inch PVC pipe that had that assembly, the ring, not just fire talk around it, it filled in the gap and that smoke stopped coming through the pipe. So what do we want? We want place safety. These are some resources that even some of the manufacturers go to when they are looking for answers themselves, so the International Fire Stop Council and the Fire Stop Contractors International Association.
Thank you, Rachel. Thank you, Rachel and Dave. We really appreciate your time and expertise. Just a reminder to everyone, don't forget to renew your membership so you can continue to receive these Tech Talks and all our other valuable benefits. On behalf of the BCA, I would like to thank everyone for your participation in today's Tech Talk and have a great day.